Three-phase induction motors are the workhorse of modern industry due to their robustness and simplicity. You might have seen that in order to start a high-power rating induction motor, a starting technique called StarDelta is used. In this video, we will understand why a StarDelta starter is needed and how it is accomplished practically. To understand why a StarDelta connection is needed, a proper understanding of induction motor operation is imperative. The induction motor has two main parts, a stator and rotor. The input power is given to the stator. When connected to a three-phase power supply, the stator of a three-phase induction motor produces a rotating magnetic field. The RMF is the one which makes the rotor turn. Let's simplify this winding to understand the connection. This is the simplest coil arrangement to produce an RMF. We have three coil sets as shown. Let's denote it with U, V, and W. The ends of each coil are represented as 1 and 2 respectively. When excited by a three-phase AC power supply, this simple coil configuration will produce a two-pole rotating magnetic field. This rotating magnetic field will induce electricity in the rotor bars according to electromagnetic induction. So, the rotor is like current carrying bars immersed in a magnetic field. This will induce an electromagnetic force according to Lorentz force law, and the rotor will rotate in the same direction as the RMF. This is how the induction motor works. Electricity is induced on the rotor bars due to electromagnetic induction rather than direct connection. So it is clear that the induction motor works due to transformer action. The stator coil acts like the primary of a transformer and the rotor bar as the secondary. Here comes a really interesting problem. Think of the rotor RMF interaction at the starting of the motor. When the induction motor starts, the rotor speed is 0 and slowly increases. This means the rotating magnetic field will cut the rotor bars at a very high rate. As the rotor gains speed, the rate of flux cut will decrease. So a high EMF and current will be induced on the bars at the start. As the rotor speed increases, the current will lower to the normal value. At the start, stator current also must be high, since the rotor and stator current are coupled due to transformer action. Due to this, the stator coils will draw a huge amount of current when the motor starts. This will produce a large voltage drop in the line and affect other devices when a heavy rating induction motor starts. How does one overcome this problem? StarDelta connection is one of the most commonly used solutions for this. You can see in the current design that all the ends of the coils are free. We could connect one free end of each of the coils in two different ways. Either as star, where the end terminals are together, or as delta, where the end of one coil is connected to the start of the next coil. This is clearly depicted in the schematic. When we apply a three-phase voltage across a star connection, each coil will receive a much reduced voltage. Whereas if one applies a three-phase voltage across the delta configuration, we will get the same applied voltage. So the trick to overcome the high starting current is simple. Just connect the coils in star at the starting. Reduced input voltage means reduced current at the stator coil. To necessitate this connection, all the terminals of the coils are fed to the junction box of the motor. They are arranged in the following manner. Input power is given to the terminal 1 of the coils. To connect in star, what we have to do is just connect the second terminals together. After the rotor achieves a considerable speed, the stator current will be normal so that we can switch to delta configuration. To switch to delta, you just have to connect the terminals as shown. However, such a manual rearrangement of terminals is practically difficult. In practice, In order to achieve this, we use contactors. Use of contactors are simple. Just draw 3 cables from the second end of the terminal. If these 3 cables are connected together, it is clear that it will result in a star connection. This is exactly what a contactor does. When this contactor is activated, that will result in a star connection. To achieve delta connection, the second terminal cables are branched and one more contactor is introduced. The second branch is connected to the input supply as shown. So, if the second contactor is closed, it will result in a delta configuration. The exact timing of contactor action is determined by a timer. We hope you developed a clear insight into StarDelta connections. Please help us at patreon.com so that LE can achieve its goals. Thank you.